Hey, y'all, this is a look back video. And in these videos, we'll tackle some work that comes out of college algebra. And the idea here is to strengthen your skills and remind you of some things that you may not have thought about in a while. So for this warm up, I've got three letters: A equals a half, B equals the square root of 3 over 2, and C equals 1 over the square root of 2. And I want you to do three things: A plus C, B times C, and B plus A times C. Shoot, let's do one more just for fun, because we've got addition and multiplication in here, but might as well throw in some subtraction. So we'll do C minus B divided by A. Okay, at this point, you should pause the video and do what you can do. And, one thing you can do is just do the A plus C, and then that's the one I'm going to talk about first. And you can do B times C. In general, as we're doing these look back videos, if you think to yourself like, oh, shoot, I don't know how to do this, or I'm not sure, you have an option to, of course, just watch me do it as a way of kind of refreshing yourself. But one of the things you may think about is what resource could I use to go back and remind myself how to do something, right? So what we're trying to do here is model a situation in this class or the next math class you take where there's some skill that's expected of you and you're like, shoot, I don't remember how to do that. And then your job basically becomes, well, I got to figure that out. I got to understand how to execute this particular part of this problem. Okay, so let me just make sure that I've got C minus B over A written down, because I think that's a new one that I just decided on. Shoot, where's my... All right, hold on, I'm going to pause this for a second. Okay, I'm back and better than ever. So, as I said, keep in mind that as we do any of these looking back videos, you're wondering about, how do I solve problems? Where do I get support? Where do I get help if I'm stuck on a problem? Of course, I'm your teacher, so you can always say, send me a message and say, can you explain something? I'm talking about external resources, right? What's available to you beyond that? You're doing work at 11 at night, and I'm not going to be able to be helpful at that time. Okay, so let's just take it from the top. A half plus 1 over the square root of 2. I need a common denominator. Now, the sort of laziest way to get a common denominator is to just multiply by the other denominator. So for instance, the square root of 2 can be multiplied by 2. If I do that to the bottom, I better do it to the top. And the 2 can be multiplied by the square root of 2. And then I have a common denominator. The 2 and the square root of 2 are not the same thing, of course. Now, this is lazy in the sense that I'm doing more than I need to do, but let's just look and see how it plays out. Generally, I'll write the whole part first. So I'm writing 2 root 2. And then as I go to add, now that I have a common denominator, I can just bring the fractions together into the same fraction, right? So this is kind of the simplest answer. There's some other options that we have in terms of, say, I could divide everything by the square root of 2. And that's really the point here, is that there was a smaller number we could have multiplied by that would have given me a common factor, a common denominator, which is the square root of 2. Because if I took 1 over the square root of 2 and I multiplied by the square root of 2, what's the square root of 2 times the square root of 2? Well, that's the square root of 4. So this is 1/2 plus square root of 2 over the square root of 4. But what's the square root of 4? Is just 2. So it's the square root of 2 over 2. So this actually, I think most people would agree, this is a simpler version of this. Now, an essential calculator skill that you want is you want to be able to take these three things and type them into your calculator. So this is thing 1. This is thing 2. And this is thing 3. You should be able to type all of these things into your calculator and see that you get the exact same crazy decimal. Okay. Here, look, I'll do it real quick. Where's my calculator? So when I add 1 plus the square root of 2, I'm just going to do the third one. I don't need to do all of it because I know how to use my calculator. I get 1.2071, you know, blah, 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 blah. That should be the exact same decimal that I see each time I do this, whether I do 1, 2, or 3. And that in itself is a evaluation technique. It's a way of knowing that you got the right answer. And one of the things that we sometimes don't talk enough about in math class is how do you know you're right? It's such a critical question because it's part of you building confidence in mathematics, confidence in your own ability to do things. And getting that from, you know, a computer program, a teacher, a tutor, that's all kind of nice external validation, but you really want to look for internal validation with mathematics. Like, how do I know that I've got this right? And what is a way for me to kind of prove it to myself? Okay, so there's the first one. Let's take a look at the second one. With addition and subtraction, we need common denominators. That's a key fraction skill. We also saw a little bit of radical work there. Square root of 2 times the square root of 2. All of that is going to be important in this course and as you go on. Next problem was b times c. So that's the square root of 3 over 2 times 1 over the square root of 2. All right. And so for multiplication, I like to say it's the easiest of all operations because you just multiply straight across. Square root of 3 times 1 is the square root of 3. 2 times the square root of 2 is 2 root 2. It's exactly the way you'd like all fraction operations to work. Some of them do, some of them don't. Multiplication is a beautiful thing. Okay. If you're thinking, was there more to do here? You know, this is one of the places where there's some gray area in mathematics, and that may seem strange, but you know, is this the most simplified form? Well, remember there was something called rationalization. And rationalization is where you try to make these rational in the sense that I want to get rid of the radical here. So how do I get rid of the square root of 2 in the denominator? And that really, this is like a very antiquated thing in some ways, because dividing by the square root of 2 is a problem if you're going to do it by hand, because if you're going to sort of write out the long division, this is a non-terminating decimal, non-terminating, non-repeating decimal. That's what a radical is. It's kind of this crazy number, right? Square root of 2 is 1.4 something. 1.414213562, and that's only as far as my calculator goes. There's more to it than that. So if I want to rationalize this, I multiply by what is radical in order to get rid of the radical, right? Because square root of 2 times the square root of 2 is a square root of 4. So this is square root of 6, because that's square root of 3 times the square root of 2. 2 times the square root of 4. So this is the square root of 6 over 2 times 2, which is the square root of 6 over 4. This is a rationalized version of this answer. Okay. And again, you can do that calculator thing where you show that these come out to be the exact same decimal. All right. Oh, Lord, I just lost everything. A equals a half. B equals the square root of 3 over 2. C equals 1 over the square root of 2. Next problem was B, square root of 3 over 2, plus A times C, a half times 1 over the square root of 2. So order of operations here, right? We're going to do what's in the parentheses first. Multiplication, so there's not really a whole lot to do. Square root of 3 over 2 plus 1 over 2 root 2. Okay. Can you see the common denominator and what we would do to get the easiest common denominator? I hope you said multiply by the square root of 2 here. Often I think a useful question in that context is what's missing, right? So that what's missing is in the left denominator, we don't have the square root of 2. So we multiply by the square root of 2 so that it's there. Square root of 6 over 2 root 2 plus 1 over 2 root 2 equals 1 plus the square root of 6 over 2 root 2. And again, that's the answer. Can it be simplified? Sure, we could rationalize it. I'll leave that to you as an exercise, and you can check that your rationalized answer is the same as this decimal. Okay, last problem. And I'm not going to clear all this time. I'm just going to use my eraser. It was C minus B divided by A. Let's take a look. So I've got 1 over the square root of 2 minus B square root of 3 over 2 divided by a half. Okay. I'm going to just quickly compartmentalize. Compartmentalization is a really fancy word. It comes from psychology, but basically what I'm going to do is I'm going to take this and I'm going to do this part somewhere else. So I can just kind of be organized and keep focused on what's important. I need to do this. Anytime I do division with fractions, I'm going to write it sideways because that's a way easier way for me to kind of envision what's happening. This is actually a fun problem because it illustrates something important about division, which is that division and multiplication are related operations. There's really no need to do the standard keep, change, flip. So first of all, there's lots of ways that people talk about dividing fractions. I like keep, change, flip. I've been teaching for 15 years in mathematics, particularly, and the cross multiplication. It's like, first of all, it reminds me of proportions. Second of all, how do you know who goes on top? But a lot of people come in with that particular tool. I like keep, change, flip because it's just a simple mnemonic device. It is. Some people turn their noses up at it because it's a trick, essentially. At the end of the day, it'd be great if you understood why multiplying by the reciprocal is the same as dividing, but it's not really necessary in terms of you being competent in terms of dealing with division. And you're going to have a lot of division of fractions in your life. So you want to be able to, make sense of it or have it be something that you're good at. Okay, now I'm just going to point out that we didn't need to do that here because we can divide straight across like that. It's the same as multiplication. Division and multiplication is the same. The reason we do keep, change, flip is that in some problems, I'll just make one up here, 9/7 divided by 4/5. Dividing straight across gives you 9/4 divided by 7/5. And I'm really no better off here than when I started. And so this is not a useful thing for me to do. However, notice that here, the division is nice. So I got the square root of 3 divided by 1. Well, that's the square root of 3. And I've got 2 divided by 2. Well, that's 1. In other words, this turns out to just be the square root of 3. I can get to the same place here, 2 root 3 over 2, simplify. Of course, I had an opportunity at the beginning there to see that the 2's were diagonally going to cancel, simplify. So, end up in the same place regardless. So the whole point is that when I do this division, I end up with just the square root of 3. So this should be 1 over the square root of 2 minus the square root of 3. Now, because I'm pairing it with this fraction of subtracting, I really need to go back to its fraction form, put it back over 1. Again, I hope you can see what I need to multiply by for that common denominator. Square root of 2, square root of 2. So this is going to be 1 minus the square root of 6 over the square root of 2 is my final answer. And again, you can check, this thing here at the very beginning, if you've written it correctly, if you know how to use your calculator, should end up giving me the exact same decimal form as this. This is not rationalized. If you wanted to rationalize it, you could, and you'd come up with another version of this that you can check again to see that the decimal is the same. One last point about rationalization, because I think that there are times, and I'm thinking about calculus in particular, where rationalization comes up. You know, you're sort of dealing with a problem like this, 1 plus the square root of 2. To rationalize this is not as simple as just multiplying by the square root of 2 or 1 plus the square root of 2, because all of that is going to leave me with radicals in the denominator. So what I need to do is multiply by the conjugate, and that is the way that I would achieve rationalization in this part. Again, to compartmentalize this, I'm going to put parentheses on that now. This is 1 plus the square root of 2 times 1 minus the square root of 2. I'm going to go over here with a different color. And this takes me back to binomial multiplication. So I distribute this is the square root of 2. It kind of looks funny. 1 times 1 is 1. 1 minus the square root of 2 is minus the square root of 2. Square root of 2 times 1 is plus the square root of 2. And square root of 2 times minus square root of 2 is minus the square root of 4. So that's 1, nothing, minus 2 equals -1. That is rationalized. There's no radicals left, right? What I'm making use of here is the difference of squares, where if I multiply a plus b times a minus b, I end up with a squared minus b squared. You can FOIL that out and show yourself why that works. So if I have a radical that I want to get rid of, but it's trapped with addition or subtraction and a whole number, then I can get rid of it by multiplying by what's called the conjugate. So the end result here would be 3 times 1 minus the square root of 2 divided by -1, because when I multiply those two things together, that's what I got, which really simplifies a lot, because now I can clean this whole thing up. 3 minus 3 root 2, and I'm divided by -1. So my answer is -3 plus 3 root 2. And you can, again, check that, plug it into your calculator against that, and see that you end up with the same thing. Well, it's kind of cool, really, that this crazy looking fraction ends up looking as something that doesn't even need to be a fraction. Okay, that's it for our looking back segment, and hope that was helpful. If it brought up any bigger questions for you, let me know. I mean, fraction skills, radical skills, so important for the work that we're going to do in this class. So if you watched this video and you thought, oh my God, I forgot everything I ever knew about those things, it's time to dig in. Don't ignore that elephant, because it will sit on you and squash you in trig. All right, talk to you later.